Hello, everyone. This is grade 7, module 5, which deals with statistics and probability. And this is lesson 2. And the title of this lesson is Estimating Probability by Collecting Data. So in this lesson, the students perform an experiment. And through the use of the experiment, they realize that the probability of an event occurring is the number of observed occurrences of that event over the total number of observations. And the experiment they perform looks something like this. They have a spinner, and the spinner is divided into 4 sections, 1, 2, 3, 4. And they basically just spin the spinner. And they record whatever results they come up with. So in this case, I spun a 3 first. Then they spin the spinner a second time. And the second time I spin, and I get a 2. So then they find the sum of the spins, 2 spins. So in this case, the sum is 5. And they do this 15 times. So they fill this whole chart in, and they do this 15 times. So let's just say that I did this 15 times. So let's delete this. We'll delete these. So let's say I did this 15 times, and these are the results that I have. Okay. From here, the students are then to answer a bunch of questions based on the experiment. So the first question is, what sum occurred the most? Now, a lot of times it may be difficult to see that just by looking at the chart. So I often have the students kind of organize this a little differently. So let's take a look at the 2. It looks like a 2 occurred 1, 2. It only came up twice. How many times did a 3 occur? Well, a 3 occurred 1, 2 times also. Let's take a look at a 4. A 4 looks like there's 1, 2, 3 4s. A 5, 1, 2, 3, 4 5s. A 6 only occurred 1 time. A 7 occurred twice. And an 8 occurred 1 time. So we can see that the one that happened the most often is a 5. Okay, the most often is a 5. Then it says, what sum occurred the least? Well, let's see. It looks like there's the 6 and the 1. I'm sorry, the 6 happened 1 time and the 8 happened 1 time. So it looks like the 6 and the 8 occurred the least. Right? Question 3 says, name a sum that would be impossible. Well, notice all my numbers are between 2 and 8, right? So is it possible that I can spin a sum that's a 10? Well, let's look at our spinner. Notice we have a 1, 2, 3, or 4 on the spinner. Well, if I spin that spinner 2 times, a 4 and a 4 is going to give me 8. A 4 and a 4 is going to give me 8. So the highest sum I can get is an 8. So I can't spin a 10. I can't get a sum that's an 11. I can't get a 12, etc. So there's a lot of different numbers. A student might say, I can't spin 100. And they'd exactly be correct. You can't spin 100. Right? Question 4 says, what event is certain to occur while playing this game? Well, let's take a look at all of our possible sums. We can get numbers that are either a 2, 3, 4, 5, 6, 7, or 8. Notice the smallest number on my spinner is a 1. Smallest number is a 1. So if I spin a 1 twice, I'm going to get a 2. Right? If I spin the highest number, which is a 4, if I spin a 4 twice, I'm going to get an 8. So all of my sums have to be between 2 and 8. So between 2 and 8. Now, there's a few ways to write this. Now, we can get a 2, and we can also get an 8. So some students might say we can get, let me erase this here. Some students might say the number has to be greater than or equal to 2 and less than or equal to 8. But other students might say, well, every number is less than or equal to 8. So you could, if you'd like, just say the sum is less than or equal to 8. Or you could say that the sum is greater than or equal to 2. Either one of those options would be correct. Okay, question 5 says, based on the experiment, what is your estimate for the probability of getting a sum exactly equal to 5? Well, let's see. We'll delete this here for a minute. Okay. Sum that's exactly equal to 5. Well, when we did this, it looks like, oops, let's undo that. Let me delete this guy right here. Let's delete that. There we go. Okay. When we got a 5, 4 times we spun a 5. So the 4 came up, I'm sorry, the 5 came up 4 times, out of how many total spins did we have? Well, notice we had 15 trials. So 4 out of 15 trials, we spun a sum that was exactly equal to 5. Question 6 says, out of 15 terms, how many times was the sum greater than or equal to 5? Well, we spun this. How many times is it greater than or equal to 5? Well, let's see. All of these times, the sum was greater than or equal to 5, right here, right? So this isn't asking us for probability. It's just saying how many times. So let's say we had 4 5s. We had 1 6, 2 7s, 1 8. So 4 and 1 is 5, 5 and 2 is 7, 7 and 1 is 8. So that happened 8 times. But now it says, based on this experiment, what is the estimated probability that the sum will be greater than or equal to 5? Well, it happened 8 times. Out of how many total spins? Well, we said that was out of 15 total spins. Now, just a note for this question. Notice this says based on the experiment. In a few lessons, maybe around lesson 6 or 7, you're going to learn about theoretical probability as opposed to experimental probability. This happened 8 out of 15 times based on our experiment. So these are all experimental probabilities. When you learn about tree diagrams, you're going to see that and realize the difference between theoretical and experimental probability. So for our purposes here, we're really talking about experimental probability based on the experiment that we're doing. Okay? And finally, it says, question 8, if you play this game 300 times, how many times will the sum be greater than or equal to 5? Well, we only did this 15 times, and 8 out of 15 times we had a sum that was greater than or equal to 5. So this was the total amount of spins that we had. We spun this 15 times. But now we're saying, what if we don't have to spin 15 times? What if we spin 300 times? How many times will we have a sum that is greater than or equal to 5? So the students from earlier in the year should feel comfortable with how they set up proportions and also how to solve proportions. So in this case, of course, we would just cross multiply. We have, let's say, 15x equals 2,400. We'll divide by 15 on both sides. Divide by 15. These guys cancel out. So if we divide 2,400 divided by 15, we come up with 160. So we would expect there to be about 160 times where the sum is greater than or equal to 5.